So, good afternoon everyone. We are here to present to you the measures of position in statistics, wherein we are about to determine the position of a single value in relation to other values in a sample or a population dataset. So, before we proceed, let me introduce myself first. I am Ken Scargatanos. Together with Crystal May Tamagos, we were going to discuss this topic with you.
What is the importance of measures of position? Measures of position give us a way to see where a certain data point or value falls in a sample or distribution. A measure can tell us whether a value is about the average or whether it's unusually high or low. Measures of position are used for quantitative data that falls on some numerical scale.
What are quantiles? The extension of the median concept where the data are divided into several parts, the quartile, decile, and percentile. These are the measures of position where the dataset are divided into 4, 10, and 100 parts respectively.
Let's discuss the quantiles of ungrouped data. The quartile. Quartile is another extension of the median concept where the distribution is divided into quarters or 4 parts. The first quartile is denoted by Q sub 1, Q sub 2 for the second quartile, and Q sub 3 for the third quartile. First quartile, second quartile, and third quartile constitute the 25%, 50%, and 75% of the dataset respectively.
In finding the positions of the quartiles, the following formulas are used. First quartile is equal to 1 times the quantity n plus 1 all over 4. Second quartile is equal to 2 times the quantity n plus 1 all over 4. Third quartile is equal to 3 times the quantity n plus 1 all over 4. Consider the set of scores in statistics of BS Ed English 1B 11, 13, 14, 15, 15, 16, 19, 19, 20. Find the first quartile. Example: the sample size is 9. First quartile is equal to 1 multiplied by the quantity n plus 1 all over 4 equals to 1 multiplied by 9 plus 1 all over 4 equals to 1 multiplied by 10 all over 4 equals to 2.5. This means that the position of first quartile is at 2.5 term. We are going to find the value of the 2.5 term. Thus, 2.5 equals to second plus 0.5 multiplied by the third term minus second term equals 13 plus 0.5 multiplied by 14 minus 13 equals to 13 plus 0.5 multiplied by 1 equals 13.5. So, the first quartile is 13.5. The decile. Decile is an extension of the median concept where the distribution is divided into 10 equal parts. The deciles are denoted by D sub 1, D sub 2, and D sub 9. First decile constitutes the 10% of the dataset, and second decile constitutes 20%, and so on. To find the deciles of the dataset, the following formula can be used. First decile is equal to 1 times the quantity n plus 1 all over 10. Second decile is equal to 2 times the quantity n plus 1 all over 10. Ninth decile is equal to 9 times the quantity n plus 1 all over 10. For the example, using the same dataset, we'll find the fifth decile. Fifth decile is equal to 5 multiplied by 9 plus 1 all over 10 is equal to 5 multiplied by 10 over 10 equals to 50 divided by 10 is equal to 5th term. So the value of the 5th term is 15. The percentile. Percentile defined as an extension of the median concept where the dataset are divided into 100 parts. These parts are divided by first percentile, second percentile, and third percentile, and up to 99 percentile. The 50th percentile of a group of numbers is the value below which lie p% of the numbers in the group. The position of the kth percentile is given by k times quantity n plus 1 all over 100, where n is the number of the data points. In symbol, first percentile is equal to 1 times quantity n plus 1 all over 100. Second percentile is equal to 2 times quantity n plus 1 all over 100. And 99th percentile is equal to 99 times quantity n plus 1 all over 100. For the example, we are going to use the same data set. Find 42nd percentile. 42nd percentile is equal to 42 multiply the quantity n plus 1 all over 100 is equal to 42 multiplied by 9 plus 1 all over 100 is equal to 42 multiplied by 10 all over 100 is equal to 420 divided by 100 is equal to 4.2 seconds. 4.2 second equals to 4th term plus 0.2 multiplied by 5th term minus 4th term is equal to 15 plus 0.2 multiplied by 15 minus 15 is equal to 15 plus 0.2 multiplied by 0 is equal to 15. So the 42nd percentile is 15. Quantiles of group data. In finding the fractals of the group data, the following formulas are used. Kth quartile is equal to lower boundary plus desired k times by the sample size over 4 minus cumulative frequency before over frequency of the kth quartile times I. Kth decile is equal to lower boundary plus desired k sample size over 10 minus cumulative frequency before over frequency of the kth decile times I. Kth percentile is equal to lower boundary plus desired k sample size over 100 minus cumulative frequency before over frequency of the kth percentile times I, where quartile is pk or kth quartile, k is desired k equals to 1, 2, and 3, n is considered as sample size, CFB known as the cumulative frequency before the kth quartile class, and FPK is the frequency of the kth quartile class, and LB is the lower boundary of the kth quartile class. Decile is where dk is kth decile, k is desired k equals to 1, 2, 3, and up to 9, n is the sample size, CFB is the cumulative frequency before the kth decile class, FPK is the frequency of the kth decile class, and LB is the lower boundary of the kth decile class. Percentile is where pk is kth percentile, k is the desired k equals 1, 2, 3 up to 99, and n is the sample size, CFB is the cumulative frequency before the kth percentile class, FPK is the frequency of the kth percentile class, and LB is the lower boundary of the kth percentile class. Let's calculate the first quartile, the 6th decile, and the 80th percentile using the given table. So the class interval or scores of BSED English 1B is 36 to 40, 31 to 35, 26 to 30, 21 to 25, 16 to 20, and 11 to 15. And for the frequency, we have the following values: 3, 9, 15, 8, 12, and 3. To find the less than cumulative frequency, we need to put 3 first and add the 3 to the frequency. So 12 plus 3 equals to 15, 15 plus 8 equals to 23, 23 to 15 is equal to 38, and 38 plus 9 equals to 47, and lastly 47 plus 3 is equal to 50. The interval here is 5 and the sample size or n is 50. For example, calculate the first quartile of the scores of 50 learners in statistics in a 40-item test. For first quartile, kn over 4 is 1 multiplied by 50 over 4 equals to 50 over 4, so the kn over 4 is 12.5. So to find the LB, let's get the lower boundary of the kth quartile of the class. And also, for the CFB, the commutative frequency of the kth quartile class. And for the frequency of the first quartile, we need to get the frequency of the kth quartile class. The lower boundary of the class is 15.5, and the commutative frequency of the class is 3, and the frequency of the kth quartile is 12. Kth quartile is equal to lower boundary plus kn over 4 minus by the commutative frequency before over frequency of the kth quartile times I, and first quartile is equal to 15.5 plus 12.5 minus 3 over 12 times 5. First quartile is equal to 15.5 plus 9.5 over 12 times 5. First quartile is equal to 15.5 plus 0.79 times 5. So the first quartile is equal to 15.5 plus 3.95 is first quartile equals to 19.45 or 20. Therefore, 25% of the students have a score less than or equal to 20. Calculate decile for group data. 6 decile class. K multiplied to n all over 10 is equal to 6 multiplied by 50 all over 10 is equal to 300 divided by 10. Therefore, 6 decile class is equal to 30. We will be using the same table that we used to solve the quartile. The lower boundary is equal to 25.5. The cumulative frequency before is equal to 23. The frequency of the 6 decile is 15. The sample size is 50 and the interval is 5. This is where the 6 decile is located. To solve, 6 decile equals the lower boundary, which is 25.5, plus the 6 decile class, which is 30 minus the cumulative frequency before, which is 23 divided by the frequency of the 6 decile, which is 15 times 5. 6 decile is equal to 25.5 plus 7 divided by 15 times 5. 6 decile is equal to 25.5 plus 0.47 times 5 equals 25.5 plus 2.35 is equal to 27.85 or 28. Calculate percentile for group data. 80th percentile class. K multiplied to n all over 100 is equal to 80 multiplied by 50 all over 100 is equal to 4,000 divided by 100. Therefore, 80th percentile class is equal to 40. Using the same table, the lower boundary is equal to 30.5. The cumulative frequency before is equal to 38. The frequency of the 80th percentile is 9. The sample size is 50 and the interval is 5. This is where the 80th percentile is located. To To solve, 80th percentile equals the lower boundary, which is 30.5, plus the 80th percentile class, which is 40, minus the cumulative frequency before, which is 38, divided by the frequency of the 80th percentile, which is 9 times 5. 80th percentile is equal to 30.5 plus 2 divided by 9 times 80th percentile is equal to 30.5 plus 0.22 times 5 equals 30.5 plus 1.1. Therefore, the 80th percentile is equal to 31.6 or 32. These are all ways and formula to solve both quantiles or grouped and ungrouped data. I hope you learned a lot from our discussion, and thank you for watching.